Let's look at some negative integer power functions. So instead of x squared, we're going to look at x and negative 2, which is the same thing as 1 over x squared. So we're looking at these negative options now. We have x and negative 1, which is the same thing as 1 over x, and x and negative 2, which is the same thing as 1 over x squared. Remember, negative exponents belong in the denominator. So there's two ways to think of it, two ways to plug into your calculator. I'm going to go ahead and plug in on this first chart first. I'm going to do negative 2 in parentheses and raise it to the negative 1 power. So negative 2 in parentheses to the negative 1 is going to give me negative 1/2. And if I do the same thing with negative 1, I'm going to get negative 1. Plugging in negative 0.5, you should get negative 2. 0 gives me undefined. I get an error in my calculator, which makes sense because this is the same exact thing as 1 over x. However you want to think about it. 1 over x is x to the negative 1. When we plug in 0.5, we get 2. When you plug in 1, you get 1. And plugging in 2, you get 1/2. So let's plot these points starting with 2, comma, negative 1/2. Negative 2, comma, negative 1/2 is about right there. Negative 1 is at negative 1. If I plug in negative 0.5 for the x, my y value is down at negative 2. If I'm over at 1, or 0.5, I'm up at 2. Then I have 1, 1, and 2, 1/2. And then that undefined y value at 0 gives me a vertical asymptote, which we're going to talk a whole bunch about. But I can't plug in 0. I get a vertical asymptote there. But off to each side, I can draw a graph by connecting those dots. There's the left side, and then here's the right side. How it's going to look. And this is f of x is x to the negative 1, or 1 over x. Would look like this. And we want to switch gears and compare it to x to the negative 2. Our g of x is x to the negative 2, which is 1 over x squared. However you want to plug it into your calculator. When you plug in negative 2, you get 1/4. Negative 1, you get positive 1 out. We get 0.5 in parentheses, negative 0.5 in parentheses to the negative 2 is 4. If you plug in 0, you still get undefined. Can't divide by 0 squared. And then these last y values, you should get 4, 1, and 1/4. So we still have that undefined spot here, our vertical asymptote. That's the same for both of them. You can't plug in 0 because it makes you divide by 0. But then if we think about what's happening to the left and to the right, if we plug in negative 2, we got 1/4 out. So positive 1/4. So maybe right here, if we plugged in negative 1, we got a positive 1. And negative 0.5, we were up at 4. So our left side connecting these dots got suddenly steep. On the right side, 0.5 went to 4 as well. 1 went with 1 as well, and 2 went with that positive 1/4. So there's our left and right side of g of x, which is x to the negative 2, or 1 over x squared. We can see the difference between having an even negative power and an odd negative power. So how do these graphs of the two functions differ? So we're going to answer about both functions. How they differ? Well, 1 over x squared is always positive. And notice that's always above the x-axis. And that's because of that even power. When you square something, it becomes positive. So the one with the odd power had some negative y values versus the one with the even power had all positive y values. It was always above the x-axis. We're going to determine the behavior as x approaches positive infinity. So we're thinking about x value going to infinity. Does that mean we're talking about x-axis? So does that mean to the left or to the right has positive x values? That's far out to the right. So if we follow to the right, if we follow our graphs both to the right, here looks like I'm approaching 0. And also here, same thing. It looks like I'm approaching 0 as we go far out to the right. We don't have up arrows or down arrows saying that we're going up without bound or down without bound. It just looks like we're getting close to 0. If we look at how they approach 0, what happens to the functions when x approaches 0? Well, we're looking between 0 and 1 approaching 0. So here's 0 and 1 on both graphs, but we're going to approach 0. So if we go in toward x is 0, it's going up to positive infinity on that one and up to positive infinity on this one. So looking between 0 and 1, but heading toward the x value 0, the graph is going all the way up to infinity. This exercise is just getting us ready to think about calculus someday and doing limits and approaching x values. Where's the y value headed? We'll just do one more. What happens if you approach the x value negative infinity? So we're going to follow the graph out to the left and say what's happening with that y value. So going back up to those graphs, we're going to follow them far out to the left because that's where x goes to negative infinity. And following each graph to the left, as I go out to the left with this one, it looks like I'm stopping at the y value 0. And same thing with this one. If I follow it to the left, my y value looks like it's also just stopping at 0. So as you follow both, you head to 0 in the y value. And there's just a picture of the difference between a negative power that is odd versus even. Our graphs look very different than when we have positive powers.